All right, so welcome to part 2 of the Algebra 1 quiz review we started in the last time. In this video, I apologize if it's a little bit longer. I'm going to try and finish all the other sections that we have to cover, which is evaluating expressions of absolute value, solving absolute value equations, solving inequalities, and lastly, solving for a variable. So if you want to just focus on one of those things, instead of watching the whole video, just try to click through and find what you need, okay? I'm going to start, though, with evaluating the expression. So these are from our quiz. We have variables defined here. We've got w equal to 0.4, x equal to 2, y equal to -3, and z equal to -10. And we have the absolute value of 9y minus z as our first example. So the very first thing we need to do is just plug in our numbers that we know. So since we have 9 times y, and y is -3, this will be 9 times -3. Minus z, and z is -10, so it's minus -10. So be careful, be aware that you kind of have a double negative thing happening there, because the minus sign is in the problem, but z is a negative number as well, so you kind of have sort of a minus sign or a negative in those two places. Now let's simplify. Let's not worry about the absolute value bars yet. Let's focus on everything on the inside here. So if you focus on everything on the inside, 9 times -3 is -27. And we can simplify minus -10 into plus 10 because the double negatives cancel. And now add these two numbers together. -27 plus 10. Keep simplifying what's in here. -27 plus 10 is -17. Now we get to the absolute value. The absolute value of -17 is simply +17. All the absolute value does is it just makes the number that's in there positive. It's not opposite, it's positive. So, for example, if, let's just say my result was the absolute value of 17, the answer would still just be 17. It's always a positive number. It's not just opposite, okay? So keep that in mind. So like the absolute value of 9 is 9. The absolute value of -9 is 9. Okay, it makes the number positive. If it's already positive, it doesn't really change it. But if it's negative, it will make it positive. So just keep that in mind. All right, in our second example, same beginning. Let's just plug in our numbers. 25 minus absolute value 5 times z, and z is -10, so it's 5 times -10 plus 1. So again, let's simplify everything that's inside my absolute value bars. So I'm not changing this 25 minus, but what I am changing, 5 times -10, which is -50. Okay, and I can now add those as well together, -50 plus 1. Okay, remember, haven't messed around with these absolute value bars, I'm just simplifying everything that's in between them. So 25 minus, but now -50 plus 1 is -49. So I've done as much as I can inside the absolute value. Now it's actually time to do the absolute value. The absolute value of -49 is +49. So this becomes 25 minus 49. All right. Now, if you're wondering why it's -49 and not +49, it's because this minus sign never changed. It's just this minus sign is gone now. Okay, so instead of having two minus signs or two negatives, we just have this one. And now we just finished the problem, 25 minus 49, which is -24. Now remember, there's no absolute value on this anymore, right? The absolute value is gone in this step. Everything after this step doesn't have an absolute value anymore. So if -24 is the answer, -24 is the answer. Don't say +24 because you think there's absolute value. There is no more absolute value. All right, that is your final answer. All right, just going to continue moving along. Moving on to solving equations that are absolute values. So let's start simple so you get an idea of how the absolute value, how these work. So here in our first example on the left, I have the absolute value of w equals 15. Now, my question for you is, what value, or what can w be? Well, w can be two different things. W can be 15, right? Because the absolute value of 15 is 15. Or w can be negative 15, right? Because it's the same thing. The absolute value of negative 15 still equals 15. So it has two possibilities. It can be 15 or negative 15. So most of these absolute value equations that we solve will have two answers. Most of them, not all of them. We'll see that in a second. Oops, skipping ahead too much, okay? So I know you see what's going on there, but let me just say what's going on. One thing to keep in mind is you can't combine anything that's outside the absolute value with anything inside the absolute value. If it's inside the absolute value, it's kind of trapped in there, okay? It's not going to interact with anything outside of it. So don't say it's 2 times x. It's not. But what we are going to do is anything that's not in that absolute value, for example, that 2, we have to get rid of it. We have to move it to the other side, or just get rid of it from the left. Right? And since that's 2 times the absolute value of x, the opposite of 2 times is dividing. So just like any other algebra, we'll divide here. So dividing by 2 cancels out with a 2, but we still have the absolute value of x equal to 9. So it's kind of like the first example. X can be two things here. X can either be a positive 9 or a negative 9. Okay, so you have your two solutions there. Now this one gets a little confusing, so pay attention carefully here. I have the absolute value of x plus 4 equals 11. Now notice the absolute value is by itself over here. There's nothing outside the absolute value, right? There's no like 4 here or plus 1 or something. Right? The absolute value is there. There's nothing outside the absolute value. But remember, I can't just dig in to the absolute value. All this stuff is kind of protected with those in those bars. So you can't just say minus 4. You can't do this. That's not how this works, because the 4 is still stuck inside the absolute value bar. So here's what I need you to think, okay? Imagine you didn't see what was in here, right? I just covered this up. You don't know what it is. You don't know it's x plus 4. I just said the absolute value of some mystery is 11. Then I would ask you, well, then what should this be? And you would say, okay, well, it must either be 11 or negative 11, right? Because the absolute value of 11 would be 11. Same thing with the absolute value of negative 11. Well, if what's in here must be 11 or negative 11, then what I'm saying is that x plus 4 must be 11 or x plus 4 a negative 11. So there are two equations here, and this is what most people forget with these absolute value problems, is to make two equations. Sometimes they just try to solve it like it's one equation, but you have to make two, because each of these will create a solution. See, both these were two solutions here. Well, there's going to be two solutions to this one as well, and this is where they come from. They come from each of these separate equations. Now the difference, though, before I finish solving it, the difference between the equation I'm working on now and the one I just solved is x is not by itself in that absolute value. That's why you get these two equations. When it's by itself, your two equations, equation 1 and equation 2, are already the answer, right? This is by itself, so the equation number 1 and equation number 2 are already the answer. But this one, it wasn't by itself, so it looks different because it's still an actual equation. It's not finished. It's not answered. But it's normal. Just do your regular math, subtract 4, you'll get your two values. So this one will be 11 minus 4, which is 7. And when you solve this equation, you have x equal to negative 15. So there's your two solutions. And if you plug them in, both of them would work. The absolute value of, if x is 7, we'll say it's 7 plus 4. Well, 7 plus 4 is 11. And we know that the absolute value of 11 is 11. So that 7 fits. And if you plug in negative 15, it'll work as well. Instead of x plus 4, it's negative 15 plus 4. And negative 15 plus 4 is negative 11. And of course, we know that that equals positive 11. So these are the two numbers that when plugged in will fit, right? The 7 gives you the positive version of it. The negative 15 gives you the negative version of it. But remember the two equations. So when it comes to this equation, another, again, like I said before, the absolute value, this stuff is trapped in there. It does not interact with what's outside of it. So you cannot multiply 2 to 3w and say it's 6w. That's not how it works. They do not interact. So your goal, just like before, is if there's anything outside the absolute value, you need to move it to the other side. So in that case, the 2. Since it's 2 times like before, we'll divide by 2 just to get rid of and cancel that 2 out. So we have the absolute value by itself equal to 6 in this case. Now remember, just like the last one, if you don't know what this is, or it's some mystery, you would say that the absolute value of 6 or negative 6 would equal 6. So I know that in here, that must be 6 or negative 6. But I know that in there is 3w. So that means 3w equals 6, or 3w equals negative 6. So there's, again, your two equations. Solve them. Divide by 3. This first equation will equal 2. And the second equation will equal negative 2. So you have your two answers. Now these two equations, when you make them, they're not far off from what you have originally, right? 3w equals 6 is very similar to what we had here, just doesn't have the bars anymore. And the second equation is pretty much the same thing, except you just have a negative here. Okay, because one's going to be for the positive version, one's going to be for the negative version. So they're very similar equations. The answers might be different, like the last one where it was 7 and negative 15. They could be similar, like these are. But you still get two answers. Now, this last one is a little bit different, and we'll talk about it as well when we get to that point. But let's start solving it like anything else. Remember that if this is in the absolute value, it's stuck in there. It does not interact with anything outside of it. So that you cannot distribute your negative 4. Okay? Don't distribute in absolute values. Remember that, okay? You cannot distribute. So that negative 4 is outside. It's always going to be outside of it. All right, same thing with that minus 1. The thing is, though, I have to move that negative 4 in that minus 1, just like a normal equation. So just like a normal equation, I'll add 1 to both sides, and that will get rid of it. So I'll have negative 4, absolute value 7 minus y, equal to 12. Remember, the 7 minus y does not interact with negative 4. If I want to get rid of negative 4, I need to divide it, since we're multiplying on that side. So divide it to get rid of it, cancel it out. We'll have the absolute value of 7 minus y equals negative 3. Now here's where we get to the interesting part. If I haven't confused you yet, I'll probably confuse you now. And if you're already confused, get ready to be more confused, okay? I'll try my best to explain this. I cannot do anything more to this problem. This problem is done, all right? There is nothing else I can do. And here's the reason why. Just like before, let's imagine this, okay? Let's imagine I cover this up. I don't know what this is. It's not 7 minus y, it's just some mystery. Let me ask you, the absolute value of what then would equal negative 3? And hopefully you're saying, well, you can't. You can't do that. Because remember, when you do the absolute value of something, it always becomes a positive number, right? The absolute value of 3, for instance, would be a positive 3, not a negative 3. If you wanted to try the absolute value of negative 3, it also would be a positive 3, not a negative 3. There's no way you can do the absolute value of anything and for it to be negative, because that's what absolute value does. It always makes it positive. So this is impossible. There's no such thing as being able to do absolute value of something and equaling a negative number like negative 3. Okay? So that means in this case there is no solution. All right. So moving on to inequalities. Well, actually, before I move on to inequalities, let's just backtrack. Those absolute values. All right, if you get to the absolute value of some stuff equals a positive number, then that means you're going to have two equations to solve, thus you'll have two answers, two solutions. Can't write words properly today. All right, so if you have absolute value of something, of whatever, and it equals positive number, you'll make two equations, you'll have two answers. If you have the absolute value of some junk and it equals 0, well, you're only going to have one equation to solve, and therefore you only have one answer or one solution. That's because there's no such thing as a negative 0, so that second equation wouldn't exist. Because if you set one equal to positive 0 and the other equal to negative 0, well, that's not any different. That's not a thing. So you just have that 1 equal to 0. In our last circumstance, the absolute value of something equals a negative number. You have to remember that this is not possible. So it doesn't give us any solutions. It's no solutions. So these are something to look out for. Again, this is when the absolute value is all by itself. There's nothing outside of the absolute value. The absolute value is the only thing remaining. Whatever's over here will help determine what kind of outcome you get. If it's a positive number over there, you'll make two equations like normal, and you'll solve them. If it's 0, it's just one equation to solve. And if it's a negative number, you need to stop right there and just call it no solutions. All right, so inequalities, if you didn't already know what those signs were, there you go. But they solve like regular math problems. The only thing you need to be aware of is the very end where you have to deal with your inequality sign. So I'm just going to skip ahead here to show you these, and then I'll work the next ones out in the next slide. But looking at the second example, right, you're trying to get the x by itself, so that means you got to get rid of this -5. So that means dividing by -5, like this. That cancels out, and you get 25 divided by -5 being -5. The thing is, though, when you divide by a negative, exactly what you're doing in this step, you have to flip the sign. You might have been told that before, but I need you to remember that. Okay, that's the only difference. That's the only important thing you need to remember when it comes to solving these inequalities. Otherwise, it's just like every other math problem, moving things from one side to the other and simplifying and whatnot. But if you divide by a negative, flip the sign. So you see here, you're dividing by a positive number. Your sign does not need to change. It's only if you divide by a negative number that your signs flip. Okay? So let's work this one out. Just like any other equation, I would start by distributing. So we'll have 27x plus 12 greater than 35x minus 4. Now, I typically like to move my x terms next, and I always want to move the smaller one, or basically any number that, or whichever one doesn't give me a negative outcome. In this case, subtracting 27x will leave me with 12 greater than or equal to, or not greater, just greater than 8x minus 4. See, by subtracting the 27, I end up with a positive 8x. If I wanted to move the 35 over there, by subtracting, 27 minus 35 would have been a negative number. And that's fine. There's nothing wrong with that. It's just when it comes to these problems in particular, that negative will mean at some point in the problem you need to flip the sign. And if you're one of those people who tends to forget to flip the sign, making the right decision here can keep you from having to even worry about that, right? By subtracting 27x, I'm not going to have a negative here, so I won't have to worry about flipping the sign in the future. So that's one of the reasons why I like to do that. Solving this like a normal equation, we're going to have 16 greater than 8x. Divide by 8, you'll have 2 greater than x. All right? I'll show the next one up here, but I won't just solve it. But if you want to take a look at it, you can look at it. that one you do have to flip the sign because at the end you divide by a negative 12. You want to pause the screen, work that problem out, you can. All right, but I'm going to move on and finish this video with our solving for a variable. Now this confuses people because they think they're trying to solve for y in the sense that they need to get y equal a number, but that's not what this means. It just means just do everything you can to get the y by itself. It's not going to equal a number, it's going to equal an equation. And that weirds people out, but it's okay. All right, so for my first example, I've got y plus 3 equals 14x. My goal is to get the y by itself, which means I got to get rid of this plus 3. Just like any other algebra, the opposite of plus 3 would be subtracting 3. So that's going to move that 3. So now the y is going to be by itself, which is what I want. That's the whole point of this. But on the right side, I have 14x minus 3. Now, these are not like terms, right? It's not going to be 11x because 14x and 3 are not like terms. I cannot combine them together. So I simply just write 14x minus 3, and that's it. That's our answer. It's an equation. It's mx plus b. It's fine. That's all you have to do with these problems. So on this example, same kind of idea. We're trying to get the y by itself, so that means I got to divide by 5 and get rid of the 5. Now when I divide, it's a little different because I have to divide everything. So the y is going to be by itself. 15 divided by 5 would be 3x. 45 divided by 5 would be 9. So just keep in mind when you divide, you have to divide everything. When you subtract or add, you only combine like terms. That's it. But when it comes to dividing, it doesn't matter what the term is, you always divide it. So this one from our quiz, it's got a couple more pieces to move. But if I want to get the y by itself, then I got to move the 3x and I got to move this minus 5. Now I'm going to start by moving the 3x. So since it's positive, I'll subtract it and it'll be gone. So now I just have negative 5y and it equals 6 minus 3x. I'm going to write this as negative 3x plus 6, only because it's more standard form. It's kind of your mx plus b. It's typical. If you write 6 minus 3x, you're not wrong. It's just, it looks backwards to me. So now I'll just divide by negative 5 everywhere. Okay, so the y is going to be by itself. Now don't freak out because this doesn't simplify nicely. It's okay. These are fractions and that's fine. The only thing you have to really worry about is the signs. When you have a negative 3 divided by a negative 5, the two negatives will cancel out. You don't have to worry about simplifying the 3/5. 3/5 is 3/5. It's cool. It's just the negatives there will cancel because the negative divided by a negative becomes positive. Similarly, on the 6 divided by negative 5, it's just going to be a negative 6/5 because a positive 6 divided by a negative 5 would be a negative number. And that's your answer. Okay? So don't worry about the fractions. Some people look at it and think it's confusing. I think you just really have to focus on making sure it's positive or negative. All right? So I'm going to end that there. I hope it helps, and apologize if it's a little longer than normal. I just want to make sure I covered everything. If you guys need anything, let me know. I'll see you in the next one.